Alright, so I'm not going to spend all the time proving these. I believe I did that back in video 4.5. Any number to a negative power will revert between the numerator and the denominator. So if it was in the numerator, it will go into the denominator and become positive. Similarly, if it's in the denominator, it will go to the numerator and become positive. Same thing happens for a fraction. If you have multiple parts with negative exponents, they will each go where they were not before. So that one, the y to the m will go to the numerator, and the x to the n will go to the denominator. The power rule of exponents says we should multiply these by negative n, so that'll become x over negative bn over y negative times a to the negative n. So that'll become y a to the n over x e to the n. Alright, so the negative exponent rules just say you switch from one to the other. Alright, so let's take a look at a couple of examples. I don't really want to spend too much time on this because we've already touched on it. You'll be asked often to simplify an expression with negative exponents and to write them with only positive exponents and no rational exponents or fractional exponents, which we'll look at in a minute. So in this example, first thing we would do is simplify the denominator. So that would stay, for now, the same. We'd apply the power rule, which will multiply the exponents of every term, including the 2, by negative 2. So that's 2 to the negative 2, x to the negative 6, y to the 14th. Now, well, to use the division rule of exponents, we will subtract the exponents from the common bases. So that 3 will stay there. The 2 to the 1, 2 to the negative 2 has nothing to cancel out with here. X to the negative 4th minus negative 6 will become x to the 2nd. Y to the 5th divided by y to the 14th would become y to the negative 9. Alright, now by applying the negative exponent rules, some things will go up and some things will come down. So the 3 will stay where it is. So as a positive exponent. The x squared will stay in the top as well. The y to the 9th will go to the denominator, and the 2 to the negative 2 will go to the numerator, so that's 2 to the 2nd, and that will simplify to be 4 times 3, or 12, x to the 2nd, over y to the 9th. Alright, one last example. That will be 2 to the negative 4th, p to the negative 4th, m to the negative 1, q to the 0, times 2m to the first, negative first, p to the third. So this was just applying the power rule. Okay, so the power is multiplied, including for the 2, which is the one that's most often forgotten. These have their own exponents of 1. Now to apply the multiplication rule, we add the exponents, so that'll become 2 to the negative 3, p to the negative 1, m to the negative 2, and q to the 0. Alright. Now we'll apply the division rule. So when we divide, we subtract the exponents. So that's 2 to the negative 4, p to the negative 2, m to the negative 2, and q to the negative 2. Now by applying the negative exponent rules, all of these terms are going to go to the denominator. So that leaves a 1 over in the numerator. So that's 2 to the 4th, which is 16, p to the 2nd, m to the 2nd, and q to the 2nd. Now let's take a quick look at the fractional exponent rule. Alright, so if we were given x to the a over b power, that can be rewritten as the bth root of x to the a, or as the bth root of x to the a. They're equal. I'm not going to get into the reasonings for that right now, but a quick example, if we had x to the 3/5, that would be equal to the 5th root of x to the 3rd. If we had x to the 5/3, that would be equal to the 3rd root of x to the 5th, which would simplify to be x times the 3rd root of x squared. Alright, so even the simplified versions aren't necessarily that much nicer, but they have no fractional exponents. Let's take a look at a bigger example. First we'll apply the power rule. So we'll get x to the x to the 5/8, y to the negative 10/4 over x squared, y to the 1/2. Now we'll apply the division rule. So that is 5/8 minus 2, which is negative 3/8. 10/4 divided by minus 1/2 would be negative 12/4. So by the negative exponent rule, this is also equal to 3, which makes things easier. That's going to be 1 over x to the 3/8 by the negative exponent rules, and that's going to be y to the 3rd. Let me write this a little more clearly. Alright. Now we can apply the fractional exponent rules. So that's 1 over x to the 8th root of x to the 8th root of x to the 3rd times y to the 3rd. I'm actually going to write this in the other order. I want the radical at the end. Doesn't really matter. Okay, now we can rationalize the denominator, which is what we learned in the previous video, which means if I multiply this by, multiplying this by the 8th root of x to the 3rd will actually not get rid of the radical. I actually have to multiply this by, so yeah, in this case we actually need 5 more radical 8s. So if we multiply this, radical 3s. So if we multiply the numerator and denominator by the 8th root of x to the 5th, we can actually get rid of the radical denominator. So that would become the 8th root of x to the 5th, the 8th root of x to the 5th power over y to the 3rd x. Alright, because these are 8x to the, this is the 8th root of x to the 8th, which is x. Alright, so that would be it in simplest form with no negative, or this would be the simplest form. So no negative exponents, no fractional exponents, and a rationalized denominator. Alright, that's probably the most complicated example you'll see. Unlikely to be more complicated than that. Let's look at something else we can do with it, which is kind of cool. Alright, so yeah, we're going to take a look at one more thing that might be kind of interesting. We can't multiply these because they don't have the same index. So we can actually rewrite these as fractional exponents. So that's x to the 5/3 times 6, x to the, that is 6/4 or 3/2. Okay, because that's 6 over 4, which is 3/2. Now we can multiply these. We'll get negative 24, x to the, we have to add these exponents, so this is 5/3 plus 3/2 is the same thing as 10 sixths plus 9 sixths, so that's 19 sixths, which is the same thing as negative 24 x to the third and 1 extra x to the 1/3, which is the same thing as negative 24 x to the third times the cubic root of x. So even though you can't multiply radicals, you can multiply the exponents. So it's an extra useful thing you can do. Alright.